Hello. Now we're going to continue with congruence conjectures, and we're going to name the congruence conjecture and state the triangles that are congruent. And we have a lot of examples. So in this situation, we have a side matching up with this side, and so on. We have three sides that match up with three sides, and we don't know any angles, so the only option is side, side, side. So we'll write side, side, side down here. And the triangles that are congruent, I'll start with the top one. I'll say angle ABC. And D matches up with A, so D has to come first. B will match up with E. And finally, we get to F. Now in this case, the second one, we have these sides matching up, these sides matching up, and the angle that's right between them matching up. So the reason for ours is SAS, and I have no idea where this K is trying to sneak away there. All right. Now, to find the triangles, I'll do KLM is going to match up with F, matching up with the K, then the X, and the O. All right, moving on to slightly more complicated. Now, we know that this side is congruent to this side. We know this side is congruent to that side. But that's all we know. However, from chapter 2, we know about angles, vertical angles being congruent. So since we know those, we also have side, angle, side, because the angles between those two sides, and this would be A, B, E. Now we have to think out, well, what matches up with A? Well, it would be D, and then C, and then E. And so now we know those two triangles are congruent. Now here we have a side, a side, a side, and a side. We don't know anything about those angles, or those angles, or those angles. But we do know this side, EG, is in both triangles. So side, side, side would prove congruence. Now, the triangle, we could do GHE. And G is this bigger angle, which would match up with E. H is going to match up with F. And then the last letter is G, because this angle and that angle are going to match up. Oh, I forgot my last S. There we go. All right, the given information, we know this side is congruent to this side. That's all we know. Now we have to think about what other relationships do we know. If this is 90 degree, that angle has to equal that angle. Also, DR is in both triangles, so that's the side. So side, angle, side, side, angle, side. We have that. Now let's look at the triangles. We have ARD and GRD. Moving on, we know M is the midpoint of AB. Since we know M is the midpoint, this side has to be congruent to that side, and those two sides have to be congruent. So that's only two pieces of information. Hopefully you know that CM is the same side, so that's in both triangles. So here we have side, side, side again. Oops. And I would say AMC and BMC. Now we have a different situation. We have parallel lines. Parallel lines, if we have a parallel line, we'll have this angle being congruent to this angle down here. We also have this angle being congruent to this angle up here. We also have vertical angles being congruent to this vertical angle here. So we can name this, say, DGO and EGL. And what conjecture proves it? Well, there's a few of them. This is actually 4 pieces of information. So on a test, if you wrote 4 pieces of information, I think that would be entirely correct. Or you could, if you use the green and the red, you could say angle, side, angle. If you use the green and the black, you could say side, angle, angle. So we know we have 2 angles and a side. And I would accept either of these as a reason for congruence. All right, this one, we have angle ADC being congruent to BCD. That's here. Angle AD being congruent to angle BC. Now the trick here is trying to figure out which triangle we're dealing with. Well, if I go down here, and I have to deal with that angle there. In the end, I have to draw that to make it a triangle. If I did that for the other triangle, it would have to look like this. So I know triangle ADC is going to match up with BCD. And that's by this, we have a side, an angle, and this side is in both triangles. So side, angle, side would be the congruence conjecture. All right. Now again, we have our parallel sides. So these sides are parallel. We know this angle is congruent to this angle. Those are alternate interior angles. And that's the only angles that we have. We know 5 is congruent to 5, so those would be equal. We know this angle is the same, or this segment is the same as itself. So we would say this is side, angle, side. And the triangle would be IBE, IBE, and ETI. Once you have those, we can move on to the next problem. Now in this situation, we have this one, these two, those two sides, and we have these vertical angles. However, that's side-to-side angle, and side-side angle does not prove congruence. So whenever you run into this, you just write doesn't prove congruence. All right, so this is a place where we can pause to ponder, to just take a break and think about what we were doing. Identify the 4 triangle congruence shortcuts. Name the 2 that don't work. So we have SSS, SAS, SAA, angle, side, angle. The 2 that don't work are angle, 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 and side, side, angle. Use congruence conjectures. Does the order you list the congruent triangles matter? Yes. Everything has to match up. All right. Here are some more problems. The more you do, the better you get at them. TS bisects MA. This tells us that MS and SA have to be congruent. MT is congruent to AT. So the third piece of information is the side in the middle, and those are congruent by side, side, side. Now if I have P as the midpoint of both of them, or M is the midpoint, we know those 2 are congruent. If M is the midpoint of AB, we know those are congruent. And by vertical angles, we know those have to be congruent. So APM, A is connected with the 2, so then we have to start with B. P is in between the 1 and nothing, so that has to be Q. And we'll finish off with M. And this is side, angle, side conjecture. All right, our last one we're going to do in this section is if kite, Ki is equal to Ti. Now, if we have that and Te is equal to Ek, a kite, this is the definition of a kite. two consecutive congruent segments. So ITE would be congruent to IKE. And the third piece of information here is that same segment. So this would be side, side, side. Now hopefully that's enough to get you through the rest of these problems. Good luck.